Good morning, Benjamin. Am I audible to you?
Good morning. Yes, you are.
Oh, that's great. We will be waiting for 2 3 minutes more so that more learners can join. Then we will start.
All right. Thanks.
There is, I'm looking for how to share up the screen. Is the screen visible to you?
Not yet.
Is it visible to you now? This is Business Mathematics and Statistics, BCOC 134. I am your academic counselor, Engineer Ashlesh Saxena. So I will be taking this course for the next 8 sessions which has been scheduled. This basically consists of two parts, A and B. Part A is business mathematics. That is, this consists of matrices, that is, introduction to matrices, determinants, inverse of matrices, application of matrices in business and economics. And today we will be talking about unit 1, 2, and 3. That is, introduction to matrices, determinants, and inverse of matrices. Now, the first question arises, what will be taught to you in matrices? That is, unit 1 is introduction to matrices, which discusses the concept, type of matrices, matrix algebra, transpose of matrix, and its calculation. Part 2, that is unit 2, is determinants. We will see how the value of the determinant is found out, what are its properties, minors and cofactors, and their application in solving Cramer's rule, and the nature of the proofs, nature of the solutions. Unit 3 is inverse of matrices. That is that defines inverse matrix, its properties, computation. We will be talking about determinants and adjoint, elementary operation root, inverse and rank of a matrix, and system of equations. And unit 4 is application of matrices in business economics. So unit 4 we will be discussing in our next session. So I will start with unit 1. Unit 1 is introduction to matrices. Matrix basically is an arrangement of numbers in rows and columns. Because of its feature of compact notion for describing sets of data and efficient method of manipulating data sets, it becomes a handy tool for finding solutions to problems which can be represented in linear equation system. Matrix algebra finds wide application covering the fields such as engineering, economics and business, sociology, statistics, physics, medicine, and information technology. For a better understanding of the application, we consider the following examples. Sociologists use matrices to study the dominance within a group. Demographers use these to study births and survivals. Industries and businesses takes the help of matrices for fast and accurate in decision making in the areas like evaluation of customers' preferences to produce and sell. These applications we will be discussing in Unit 4 when we will be taking up the practical example. We use linear programming techniques that is based on matrix formulation of data to maximize profit and thus plan production or availability of raw material. The use is also made of the matrices to arrive at a decision on the location of business, marketing of a product, or arranging financial resources. Economists use matrices to examine inter-industry flows for studying game theory and to construct the system of social accounting. As far as your medicine studies are concerned, scientists use data in matrix form to determine a statistically valid rate of efficacy of a drug before prescribing it in the hospitals and pharmacies. Many IT companies also use matrices as data structures to track user information, perform search queries, and manage databases. Now, that was why we are studying matrix. Now the part starts. What actually matrix is? As I told you in the beginning, that matrix is basically arrangement of numbers in rows and columns. Here you can see that this is a rectangular array of n into n numbers arranged in m rows and n columns. Remember, whenever we will be using m into n, that means first of all, first number will be the number of rows, and the second number will be related to number of columns. You can see within the brackets there is A11, A12, A13. If we talk about A11, that is the element of A, first element of matrix A, and it is represented as A11. A11 means first row, first column. A12 means first row, second column. A13 means first row, third column. Similarly, if we talk about A33, A33 means third row, third column. Now, what are the different types of matrices? First of all, we will start with row matrix. Row matrix means all the elements are in the row form. We have single row and the elements are -3, 0, 1. And the element or the matrix is represented by A equal to Aij 1 into n, because our normal notion for representation is m into n. So here m is 1 and n is 3. Then comes your column matrix. That means all the elements will be in the column form. -2, 0, 2, 1. The representation of the element is made by Aij n into 1. In row matrix, it is 1 into n, and in column, it is m into 1. Then comes your square matrix. Square means, if you talk in terms of square, square is a geometrical figure which has all sides equal. So in matrix form, number of rows and number of columns are same. If number of rows and number of columns are same, it is a square matrix. And the elements of the matrix is represented by Aij m into n. That means, on the other hand, we can say that in a square matrix, we have equal number of rows and equal number of columns. Now, we talk about diagonal matrix. Diagonal matrix is a matrix. It is no doubt a square matrix in which diagonal elements are there. In the given figure, you can see that 1, -3, 1, 2. These are the elements in the diagonal position only. And rest all the elements are 0. This is a perfect example of diagonal matrix, in which elements in the diagonal form are there and rest all other elements are 0. If in place of zeros there is any number present, then in that case it won't be an example of diagonal matrix. Then comes your scalar. Scalar matrix is a matrix. No doubt it is a square matrix in which in the diagonal position all the elements are same. You can see over here it's -3, -3, -3, and -3. Rest all elements are 0. Am I audible to you? You are getting it what I am saying?
Yes, sir. We can hear you.
If if you find some problem, you are free to ask me anytime. Now we move to identity unit matrix. Now see, identity unit matrix is a matrix No doubt it will be a square matrix in which diagonal elements will be one only. Rest all other elements will be zero. Correct? In scalar matrix, it won't be one. It can be any number, but that number has to be same. That is your scalar matrix. And if the diagonal or the numbers are one, then it is a identity or unit matrix. Then comes your null matrix. Null matrix, as null means all the elements are zero. It will be again as mathematically that doesn't mean anything, but when we are solving it or we are taking, we are generating some relation, we normally keep null matrix. Then comes your equal matrix. It's very simple that two things can be equal only when everything is same in both of the things. If we talk in terms of matrix, if we have 2 by 2 matrix and the another one is also a 2 by 2 matrix, and in between we have an equal to sign, then we can say that these matrices are same or these matrices are equal. We have to keep one thing in mind: both the matrices have to be of the same order. Now, talking in terms of for the equality of matrix, two matrices are equal if the following three conditions are met. Each matrix has the same number of rows, each matrix has the same number of columns, or what I said, it is has to be of the same order, and corresponding elements within each matrix are equal. Here, we take up this example. We can see that matrix A has 2, x, y, and 3, and matrix B has 2, 3, 4, 3. You can see that 2 and 3 in matrix A and 2 and 3 in matrix B diagonally are same. That means if these two matrices are same or are equal, straight away x will be equal to 3 and y will be equal to 4. This is the basic condition for equality of matrix. Now, addition and subtraction of matrix. We have to keep one thing in mind, that when we talk about addition or subtraction of matrices, both the matrices to be added or subtracted have to be of the same order. That means number of rows in the first one and the number of rows in the second one should be same, and number of columns in the first one and the number of columns in the second one should be same. Here we take up an example of A is 023 214 and B is 735 5 minus 1 minus 3. Now we are asked to add these two matrices. So when we will be adding these two matrices, it will be nothing but A plus B. They will be written in this form. Now, when performing the additions part, 0 will be added to 7. Another thing is that, first of all, we can see that number of rows are 2 in matrix A and number of rows in matrix 2 is 2. Number of columns are 3 in matrix A and number of columns in matrix B is 3. That means it is a same order matrix of 2 by 3 form. We can add these. That means now how addition will be done. 0 will be added to 7, 2 will be added to 3, 3 will be added to 5 in the same order. We cannot change the order. Your answer will be again with 2 by 3 matrix form. 2 will be added to 5, 1 will be added to minus 1, and 4 will be added to minus 3. While calculating this, we will be getting 758 701. It is having the same order, that is of A and B. It is a 2 by 3 matrix. Is that clear? How addition is done?
Yes, sir. So Can we get the video later,
And
sir?
yeah, when we can we get? Can you repeat up your
Sir,
question?
can can we be sent? Can we get the video later? The recording.
Yeah, yeah. Of course, it is recorded. Every session will be is recorded one. Nothing to worry. But when you are present in the class, I request everyone, or I want everyone to be present with a piece of paper and a pen. It will be convenient for you to understand the subject. So this was related to addition. Similarly, same thing applies for subtraction. The odd, first of all, the order will remain the same in both A and B, and we have to subtract. Now you see, A is 023,214, and the B one is 735, 5 minus 1 minus 3. We have to subtract. That means we will be subtracting 0 minus 7, 2 minus 3, 3 minus 5, 2 minus 5, 1 minus minus 1, 4 minus minus 3. So we will be getting minus 7, minus 1, minus 2, minus 3, minus 2, 7. Sorry, minus 3, 2, and 7. You can again see the order is the same, that is of A and B. That means, I'm repeating just in a second, that for addition and subtraction of two matrices, the matrix has to be of the same order. If they are of the different order, we cannot perform addition or subtraction. Now, after addition and subtraction, this multiplication of matrix by a scalar quantity comes. That means we will be talking about how this is somewhat tricky. You have to understand it. It's somewhat tricky and somewhat applicable. So we have to be 100% present what I will be discussing now. That is related to multiplication of matrix. Whether it is matrix solution or determinant solution or its application. In maximum of the problems, multiplication has to be done. Now, multiplication by a scalar quantity means we have to multiply by a quantity. That scalar quantity we will be taking lambda in this case, and that lambda will be multiplied by all the elements of the matrix. If we have what I told you that lambda is a scalar quantity, then the elements are represented by Aij, and cross n is the order. When we are multiplying by lambda, so that means every element of matrix A will be multiplied by that scalar quantity. You can see the example over here. If your matrix A is 7, 3, 5, 5 minus 1 minus 1, we have to multiply it by a number. That means, suppose in this case we have 3. So we'll have to multiply 3 with this matrix. That means all the elements of the matrix A will be multiplied by 3. That means it will become 21, 9, 15, 15, minus 3, and minus 3. This is multiplication by a scalar quantity. Or we can say that every element of the matrix will be multiplied by that number. Now, these are some of the properties of addition of matrices. Addition of matrices is commutative. That means if we are adding A plus B, it will be similar to B plus A. If we are reversing, so the order will remain the same. Second one, addition of matrices is associative. That means if we are adding three matrices A, B, and C, suppose you want that A plus B should be added first, then you will be adding with C. And on the other time, you want that B plus C should be added first, and then you will be adding A. In both the cases, your answer will remain the same. Third one is existence of additive identity. Everybody we are aware of, as I told you earlier also, 0 is a null matrix. Mathematically we use it, but algebraically it does not have any importance. That means a plus 0 is equal to 0 plus a, and the answer will remain a. Then comes your existence of additive inverse. We may get a problem related to additive inverse. For that, you have to remember that a plus minus a is similar to minus a plus a, which is equal to 0. If you are adding with the opposite sign of the same matrix, your answer will be 0. Similar to 1 minus 1 is 0. Now we see we have three matrices A, B, and C, and your zero matrices. Because the problem A and B and C all are of 2 by 3 matrix form, your zero matrix, null matrix will be of the same order, 2 by 3. 2 is representing rows and 3 is representing columns in all these matrices A, B, and C. When we are adding A plus B, that means 1 will be added to 5, 3 will be added to 1, 5 will be added to 3, 5 will be added to 6, minus 1 plus minus 1, minus 1 plus 2. So we are going to get 6, 4, 8, 11, minus 2 and 1. Now we will be adding B plus A in that order. B plus A and A plus B, your answer will remain the same, but order will change. When this order is changed by B plus A, again you are going to get the same matrix. That is what it was told to you, that A plus B will be equal to B plus C. Now we move to A plus B plus C. We have three matrices. We have seen A plus B, that is 12, 5, 1, 9, minus 2, 6, and B plus C is 11, 2, minus 4, 4, minus 1, 7. If we are adding up A plus B plus C, we are going to get 12, 5, 1, 9 minus 2, 6, which will be same as A plus B plus C. You have seen it at the top. That is the second position, second property what has been taught to you. Then comes your A plus 0. A plus 0 is will remain the same. We will be adding 0 to all the elements. It will remain as the original matrix A. Now, we talk about A plus minus 1. That means we will be multiplying all the elements of A by minus 1. All the elements, not a single element, but all the elements will be multiplied by minus 1. That means your scalar is minus 1 over here. And it was taught to you that a scalar quantity, when it's multiplied by a matrix, it is multiplied by all the elements. That means the sign of matrix A will change. Plus will become minus and minus will become plus. What you get? 0. 0, 0, 0, 0, 0. Same in the form of 2 by 3 matrix. That means your answer is A. Now comes your negation of a matrix. Negation is basically multiplying all the elements by minus 1. Now, if we talk about subtraction of two matrices, no doubt mathematically it is A minus B, but we can do one thing, A plus minus B. It is basically for knowledge purpose. We don't change up the signs. Now comes the most important part of your matrix determinant and its application. Wherever it is, multiplication of two matrices. I'm just dealing with the basic differences. In matrix addition and subtraction, the order has to be same. Then only that operation addition and subtraction can be performed. But in case of multiplication, we have to keep one thing in mind: the number of rows and number of columns of the two matrices. The requirement of multiplication is the number of columns of first matrix is equal to the number of columns of the second matrix. Number of columns of the first matrix must be equal to number of rows of the second column. That is the basic requirement. Number of columns of the first one must be equal to number of rows of the second. If the matrix A is order of m into n, that means it has m rows and n columns, then matrix B must have an order of n cross P, where n is the number of rows and P is the number of columns, which is not necessarily equal to m. Then the question arises when the number of columns and number of rows of the two are same, irrespective of the columns of the other one. Your answer of the product will be of the order m cross b. You can see it's written over there. C is equal to a cross b. The order will be m cross b. Number of rows, uh, number of rows of the first and number of columns of the second one. M cross b. Now we will see mathematically this is something how it is denoted. We are talking denoting Aij for elements Aij of matrix A, and for matrix B are representing it by Bij. When we are multiplying, we are going to get Cij. Correct. Now, how this multiplication is performed? Now see, we have two matrices. This is somewhat, pay attention to what I'm saying right now. This is one of the most difficult part of this whole matrix and determinant. You have to be very careful. You have matrix A, 1, 3, 5, 5 minus 1 minus 1. In this, we have 2 by 3 form. That means we have 2 rows and 3 columns. I'm talking about for matrix A. And in matrix B, we have 3 rows and 3 columns. What has been taught to you? That the number of rows of matrix 1, number of columns of matrix 1 must be equal to number of rows of the second. So here we have 2 cross 3 for the matrix A and 3 cross 3 for matrix B. Your answer will be a matrix of the form 2 cross 3. You can see over here I have joined these two. Your answer straight away 2 by 3 matrix. Now we'll see how this 2 by 3 matrix will come. You can see this is the answer: C11, C12, C13, C21, C22, C23. Now the question arises how this will be performed. Now pay attention. 1 is multiplied by 0. I'm talking about C11. Each element over here will be multiplied by every element over here. 1 into 0 plus 3 into 5 plus 5 into minus 1. We are going to get 15 minus 5, that is 10. 10 is over here. Second, C12. C12 means first this row and second this column. 1 into 1 plus 3 into 2 plus 5 into 2. That comes out to be 1 plus 6 plus 10. That is 17. You can see over here. Then comes C13. C1 and 3. 1 into 2 plus 3 into 1 plus 5 into 1. This comes out to be 10. Here it is. Now we move to C21. C2 is this one and 1 is this one. 5 into 0 plus minus 1 into 5 minus 1 into minus 1. This comes out to be minus 4. C2, 2. 5 into 1 plus minus 1 into 2 plus minus 1 into 2. This comes out to be 1. Then C2, 3. C2, 3. 5 into 2 plus minus 1 into 1 plus minus 1 into 1. This comes out to be 8. Now we will be placing all these numbers in this form, which is identical to this. C11 is 10, C12 is 17, C13 is 10, C21 is minus 4, C22 is 1, C23 is 8. Your, this is the matrix C. That means product of A and B. You can see this. These are the two rows, and these are the two rows, and these are the three columns. Your answer is 2 by 3 matrix. Straight away, while seeing to the order of matrix, you can find out the answer of the matrix, what you will be multiplying. We take up another example to make you understand how this multiplication is done. This is A 2 3 minus 1 5, and B is 1 minus 3 minus 2 minus 1. What I told you, 2 will be multiplied by 1, and 3 by minus 2. Then comes your 2 multiplied by minus 3 and 3 by minus 4. This comes out to be here. Then minus 1, 1 plus 5 into minus 2. This is minus 11. Minus 1 into minus 3, that is 3. Plus 5 into minus 4, that is minus 20. This comes out to be 70. So this is your answer. Now we will see how the multiplication of different orders is done, and how we get the answer without multiplying the two matrices. Here you see there are 5 problems over here. We are simply multiplying. This is a matrix of order 1 by 2. 1 row, 2 columns. And this is a matrix with 2 rows and 1 column. That means the columns are here are same as rows over here. Our answer will be 1 by 1. You can see over here 1 by 1. It will be a straight number. How this number will be? We will be get 2 into 4 plus 3 into 5. 4 into 2 is 8, and 5 into 3 is 15. 15 plus 8 is a 20. So we get a matrix of 1 by 1. That means it will be a single number. Then we move to a matrix of 1 by 3. We multiply by 3 by 1 matrix. Again, we are going to get a number, because 1 and 1 by this format. 1 by 1 is a number. 5 multiplied by 2, 10, plus 3 into 6, 18, 18 plus 28, 15, 18 plus 10 is 28, and 28 plus 28 is 56. Now, another thing is 2 by 2 matrix by 2 by 2. Your answer will be a 2 by 2 matrix. This is a 2 by 3 matrix multiplying by a 3 by 2 matrix. Your answer will be a 2 by 2 matrix. You can see over here. Now here, 3 by 2 multiplied by 2 by 3. Your answer will be a 3 by 3 matrix. This is the most important part for the matrix multiplication. Without multiplying, we are getting the order of your answer. If you make or commit some error while multiplying, you can remember one thing about the order. You can recheck the problem where you are getting an error. In the other words, 3 by 3 matrix, or we will be doing 3 by 3. That is something a tedious stuff. You can see over here how this 3 by 3 matrix is performed. A multiplied by J plus B into M plus C into P. I will be showing up the first row. B into K plus A into K plus B into M plus C into Q. And your third one will be C1 3. A into L plus B into O plus C into R. Similarly, we will be doing P into J plus E into M plus F into P. Or the other word, we can say that all these elements will be multiplied by all these elements and they will be added up. Here you can see these three elements are multiplied by respectively by these three elements and we are going to get a number. This one, this multiplied by this. Third one, this multiplied by this. When we move to second row, this is this multiplied by this, so we get this. Then this multiplied by this, we get this. Third one, this one with the third column, we get this. Third row and first column. This by this, we get this. This by this one, we get this. Then this by this, we get this. This is a 3 by 3 matrix, and this is a 3 by 3 matrix. Your answer will be a 3 by 3 matrix. This is a 3 by 3 matrix. Is that clear, or I should repeat it once again?
Hello, sir. We need more flashback, please, on this.
Sorry?
I say we need more flashback on this, sir.
Okay, I will see if we have another problem over here, how it can be, because this is what you have to remember. Because multiplication is a tedious job. We have to be very careful while we are performing this problem. Now you can see we have another problem. It is again a 3 by 3 matrix. Multiplication is there. What you remember? 1 into 1 plus 1 into 2 plus 1 into 3. That means, I'm repeating, all these elements will be multiplied by these elements. So we will be getting this one. Another one, this, all elements will be multiplied by this. 1 into 1 plus 1 into 2 plus 1 into 3, 5 plus 1, 6. This will be 6. Then this multiplied by this, 1 into 1 plus 1 into 2 plus 1 into 3. And again 6. Secondly, we will be multiplying all these elements with 1, 2, 3. 2, 2, 2 with 1, 2, 3. 2, 1, the 2 plus 3, 2 into 2 plus 2 into 3. This comes out to be 12. Then this by this. 2 into 1 plus 2 into 2 plus 2 into 3. Again 12. Third one, 2 into 1 plus 2 into 2 plus 2 into 3. Again 12. Now 3 by 1, 3 into 1, 3. 3 into 2, 6 plus 3 into 3, 9. This comes out to be 18. Again, we are going to multiply this with this, and again in the third one, this into this. So we are going to get a matrix of order 3 by 3 once again. When we are multiplying two matrices of same order, we are going to the product as of the same order. Now, for two matrices A and B, if A and B and B and A are both defined, then it is not necessary that they are equal. You will see this. If we have a matrix A equal to 1, 3, 2 minus 1, and B is 1, 2, 3, 4. Yes, yes, please.
Sir, I want to ask, sir, can we get the video recording after class?
Can we get the schedule? Schedule is already what has been told to you is in the LMS only. and the videos will be available in your LMS.
What do you say, sir?
You are asking about the schedule.
Hello, sir. Can you? No, sir. I said we get the video recording of class immediately after class. Can it be sent to the video recording, the teaching?
Video recording will be available in your LMS portal after the class is over.
Okay. Okay. Thank you very
All the
much, sir.
videos, all the sessions are recorded, and you can access them
Okay.
at your will once the session is
Okay,
complete.
sir.
And,
Okay.
and if you have any problem, you can ask me on next meeting when we have.
Thank you very much, sir.
So I will be continuing for two matrices A and B. If AB and B and A both are defined, it's not necessary that they are equal. See over here, A is 1, 3, 2 minus 1, and B is 1, 2, 3, 4. We are multiplying AB. We are getting 10, 14, minus 1, and 0. And we are reversing it, and we are multiplying B by A. We are getting 5, 1, 11, and 5. Going back to addition part, the answer was same. But in multiplication, the order is same, but your answer is not the same. The product is not the same. No doubt, the matrices are of the same order. Now, for two matrices A and B, if AB is equal to 0, it is not necessary that either of A, B is a null matrix. A is 1, 0, 0, 0, and B is 0, 0, 0, 1. Then we are multiplying A by B. We are getting 0. Here, neither A is 0 nor B. What are the properties of matrix multiplication? Associativity. Matrix multiplication is associative. That means if you multiply AB first and you multiply by the answer with C, you will be getting the same if you multiply B and C first and then with the product of B and C, you multiply A. But it has to be in this order only. AB to C will be equal to A into BC. As far as the distributive property of addition is concerned, matrix multiplication is distributed over matrix addition. For three elements A and B and C of the respective order, M cross N, N cross P, and P cross Q. Your answer will be A into summation of B plus C will be equal to AB plus AC. Then now comes identity matrix. I told you identity matrix is a matrix in which the diagonal elements are 1 and all the other elements are 0. Now the question is how it is represented. It is represented by IN. IN is related to the number of diagonal elements, number of 1 in the matrix. I3 means a 3 by 3 matrix in which the diagonal will be 3 ones. I2, identity matrix, 1 0 0 1 in which two diagonal elements of 1 will be there and remaining will be 3. If we are going to multiply it by IN, A will be equal to A into IN, which is similar to matrix A. Now we will see whatever has been taught in theory is over here to see a practical glimpse of what I said. is similar to that or not. If we have a matrix of A, 1, 2, 3, 4, B, 1, 0, 2, minus 2, and C, 1, minus 1, 0, 1, we will be performing different activities that is related to multiplication, their order, and end. First of all, we will start with AB. AB are in a single bracket. That means initially we will be multiplying AB first. When we are multiplying AB, so we are getting 5 minus 6, 11 minus 2. And now this AB will be multiplied by C. When this is being multiplied by C, C is your matrix 1 minus 1, 0, 1. The answer comes out to be 5 minus 11, 11 minus 20. Now going to the second part of it. That means over here. We have to now multiply BC first. I said order has to be kept in mind. We will be multiplying BC over here. We are getting. Now we will be multiplying this with A. That means A will come first. Then BC will come. You are going to get the same matrix. That means this one is correct. First property is correct. AB, when multiplied together, is multiplied by C. The product of the three will be similar to B and C multiplied together by A. And the order will be A into BC. If we talk about the second part, that is A into B plus C, will be equal to AB plus AC. We will see over here. The B plus C is, we will be adding B plus C, we get 2 minus 1, 2 minus 3. We will be multiplying in the same order A into B plus C. Your A matrix A will come in front of B plus C. We get 6 minus 5, 14 minus 8. Now, we will be multiplying AB. We are going to get 5 minus 6, 11 minus 8. AC. When we are multiplying AC, we are going to get 1, 1, 3, 1. Now we will be adding A plus AB plus AC. We are going to get 6 minus 5, 11, 14 minus 11, which is similar to your this answer. This answer and this answer is same. That means we can say that A into B plus C is equal to AB plus AC. Third one, we will be taking identity matrix. Here you can see that IA. A is a 2 by 2 matrix. That means your identity matrix will be a 2 by 2 matrix. And identity matrix is that matrix in which diagonal elements are 1 and remaining all other elements are. Now we will be multiplying this. We are going to get 1, 2, 3, 4, which is similar to A. Now we will be changing the order. We will be multiplying A with I. We are going to get 1, 2, 3, 4, which is similar to A. That means if the order is I into A, will be similar to A into I, and which will be equal to your original matrix. Transpose of matrix is basically interchanging of rows. Two rows are like this and columns are like this. So I will be changing these rows into this one. When we are doing it, or we can say that when we are interchanging the rows and columns, it is transpose of the matrix. And transpose of the matrix is represented by A dash or AT. That doesn't make any difference. AT or A dash. What you can see that A dash. Now, there are again some properties which are related to transpose of the matrix. We have a matrix, we transpose it, and we again transpose it. We are going to get same matrix, the original matrix. If we have A dash, So when we will be opening it, we will be taking K out. K is a scalar quantity, and it will be producted. It will be a product with A dash. A plus B dash will be equal to A dash plus B dash. Transpose of identity matrix is an identity matrix. Now see, you have to be careful in the fifth property. It is AB transpose. AB transpose will be equal to B transpose into A transpose. AB transpose is equal to B transpose into A transpose. Now we will see what has been taught, what has been discussed, how it is practically performed. We have a matrix A 2 3 0 1, matrix B as 3 4 2 1, and matrix identity 1 0 0 1. The question arises, why identity matrix is 1 0 and 0 1? If you go back to A and B, it is of the order 2 by 2. No doubt, identity matrix will be a 2 by 2 matrix only. A dash. A dash means transpose of A. I said rows will be converted into column. That means your first row is 2 3. So it will be converted into column. Your this row will be transformed to in this row. Now this will be transformed to the rows has been transformed to column. Now when you will be transposing this again, what is going to happen? This will come over here and this will come over here, which is similar to your original matrix. Correct? Now we have 3A. That means we will be multiplying all the elements of the matrix 2301 by 3. This comes out to be 6903. Now we have 3A transpose. We have 3A this. We have to transpose it. So its transpose will be this row will be written as over here, and this row will be written over here. Now 3A dash. 3A dash, what we will be doing? We will be taking 3 common from everywhere. So that means 6 divided by 3 is 2, 9 divided by 3 is 3, 3 divided by 3 is 1, and 0 divided by 3 is, we are getting this. What is this? Same matrix. Now we move to A plus B. We will be adding A plus B. So it will be 5 7 2 2. Then your question comes A plus B transpose. A plus B transpose means the column, the row will be converted into column. That means 5 7 over here will be 5 7 over here, and this 2 2 will be here. Now A transposes this row will be over here, and this row will be here. Your B transpose will be this will be here, and this will be here. Add up. You can see over here only A plus 3 is 5, 0 plus 2 is 2, 3 plus 4 is 7, and 1 plus 1 is 2, which is similar to the third one. The last one what we have to multiply AB. A is 2301 multiplied by 3421. We get 12, 11, 2, and 1. AB transpose, that means this 12, 11 will come over here, and this 2, 1 over here. Now B transpose, we will be doing V transpose means 3, 4, 2, 1. 3, 4, 2, 1 with A transpose. A transpose is 2, 3 and 0, 1. And we will be multiplying these two. This will be 6 plus 6, 12. 0 plus 2, 2. 3 plus 8, 8 plus 3, 11. 4 plus 0 plus 1. This is similar to, that means AB transpose is equal to the product of B transpose and A transpose. Now, we move to another property of a type, that is symmetric matrix. A matrix is symmetric matrix if A transpose is equal to your original matrix. That means A transpose is equal to A. We have a problem over here. It is 1, 5, 4, 5, 2 minus 1, 4 minus 1, 3. When we are talking about to get the transpose of it, that is A dash. So this order will change as 1, 5, 7 will come over here in the column, 5, 2 minus 1 in the second column, 4 minus 1, 3 in the third column, which is similar to A. Here we can say that this is a symmetric matrix. And symmetric matrix is that matrix in where A is equal to A transpose. Then comes your skew symmetric matrix. A skew symmetric matrix is a matrix in which A transpose is equal to minus of A. Now the question arises, what is meant by minus of A? We will be multiplying, or we have to find the transpose of it. A transpose over here will be 0, 5, 4, which can be written as like this, minus 5, 0, minus 1 like this, and minus 4, 1, 0 like this. We take minus common from all the elements. This is your original matrix. That means A transpose is equal to minus. This is a case of a skew symmetric. Then comes your orthogonal matrix. Orthogonal matrix is that matrix when we multiply A with A transpose is equal to A transpose into I, and that I, that's the A transpose into A is equal to I is an identity matrix. You can see over here, we have A, 1, 2, 2, 2, 1, minus 2, minus 2, 3, minus 2, 2, minus 1. Its transpose will be, this row will be coming over here, this row over here, and this row over here. Now we have A and A transpose. We multiply these two. When we multiply these two, this 1 by 3 into 1 by 3 will be 1 by 9. And we will be multiplying this by this. This is a 3 by 3 matrix. If this is again a 3 by 3 matrix, your answer will be a 3 by 3 matrix. This comes out to be 9, 0, 0, 0, 9, 0, 0, 0, 9. Take 9 common from everywhere. Well, when you're taking 9 common from this, you're getting, because your 999 is a scalar quantity, that means you will be taking 9 away, and you will be multiplying this 9 by 1 by 9, which is 1, and remaining over here will be an identity matrix of order 3, which is. Now secondly, we can also prove that if A transpose, this is being multiplied by this. Here we have multiplied this by this. Now the second case, this will be multiplied by this. Again, when we will be performing this activity, you will be getting, yes please.
Sorry, would you kindly repeat on how to multiply? I missed out on that point. I was having some problems with my network.
Acha, you missed out how to multiply.
Yes, on the part of multiple
Okay, okay.
the matrices.
Just a minute. Before starting determinant, I will again tell you how this multiplication is done. Just me finish it off. Okay. Now we will be going back for the multiplication. This is a problem which is related to multiplication of two matrices. This is our simple case because both the matrices are of the same 3 by 3. Your answer will be a 3 by 3 matrix. Now the question arises how this multiplication will be performed. We will start from here. We will move it like this and we will be multiplying with this. You can remember this way. Move in here, reach over here, come down. Move here, come to this part, come down. For the third one, move this way, come over here, come down. 1 into 1 plus 1 into 2 plus 1 into 3. Here it is. Second one, 1 into 1 plus 1 into 2 plus 1 into 3. This one. 1 into 1 plus 1 into 2 plus 1 into 3. This one. Again, repeat the same exercise. This one, move this way, reach over here, come down. This way, come down. This way, come down. 2 into 1 plus 2 into 2 plus 2 into 3. Here it is. 2 into 1 plus 2 into 2 plus 2 into 3. Here it is. 2 into 1 plus 2 into 2 plus 2 into 3. Here it is. Similarly, move this way, come down. Move this way, come down. And again move this way and come down. 3 into 1 plus 3 into 2 plus 3 into 3. 18. Again this way, come down. 3 into 3, 3 into 1, 3 into 2, and 3 into 3, 9. This comes out to be 18. This way, come down. 3 into 1 plus 3 into 2 plus 3 into 3. Again, it comes out to be 18. Is that clear now?
Yes, it's very clear. Thank you so much.
Thank you. Here again, you can see what I performed, what I did. I told you, move this way, come down. Move this way, come down. Move this way and come down. You can see it's written over here. For the second one, this way, come down. This way, come down. This way, come down. It's written over here. Thirdly, these three elements will multiply by this. These three with this three. And this three with this three. It's written over here. Okay. Now we move to the second part, that is determinant. Determinant is the value of the matrix. We have seen different properties of matrices. Now we will be doing, as I told you, that determinant is the value of the matrix. And value is a number. And to every square matrix, we assign a number called determinant. It is basically represented as mod A. Mod A is equal to A. Now the thing is as how this mod A or determinant of a matrix is calculated. Listen to it very carefully. It's very interesting part now. We have a matrix A11, A12, A21, and A22. We have to calculate its value now. So that A, see the difference over here. This is A only and here it is written as mod of A. These two parallel lines. What we are going to perform? We will be multiplying this with this with this. Here it comes. Place a minus sign, come this way or this way. That doesn't make any difference. Either you multiply by this and or with this or this. These numbers are not going to change. Value of a 2 by 2 matrix, it will be a number. Remember, matrix will be a number. As a determinant, value of the matrix determinant will be a number. We will be getting this. Here you can see that if we change it in terms of ABC4 real numbers, what we will be doing when we will be calculating the value, either we can denote it by A mod or with D. So D is equal to A into D minus B into C. Now the question arises, what we will do, how it will be different if we get a 3 by 3 matrix. That is much more important to understand what I will be doing. Here at the top you can see that is the mathematical relation what we have found. But it is very important to understand how this is performed. Listen to it very carefully. This is a 3 by 3 matrix. All the elements are given to you. You have to determine its value. How to proceed. Listen to it and see to it. Choose this A11. Write it over here. Remove this and remove this. That means remove this column and remove this row and remove this column. You are left with this. Okay. Second one, place minus sign. Pick this one. You can take this one or this one. It's your choice. That doesn't make any difference. Here I've taken this one. What I'm telling you, that doesn't make any difference. Answer will remain. Try to understand what is the methodology. Second one, I will be taking this one with minus sign. And I will be removing this and I will be removing this. So I will be left with A21, A23, A31 and A33. You can see over here, it's written over here. Third one is either you take this A31 with plus sign. A13, you will be removing this and you will be removing this, so you will be left with this. And we will be performing multiplication. Now we will pick up the problem. This is what I've told you. We take up A11, remove this and remove this. You are left over with this. Second one, place a minus sign, pick this over here, remove this, remove this. You are left with this and this, this and this. Third one, pick this, add a plus sign. Remove this, you will be left with this. Now we will see with a problem, how it is performed. What are the properties of determinants? The determinant of a square matrix is unchanged when its rows and columns are interchanged. You can see that transpose has been done. When we will be calculating its value, that means when we will be solving this determinant, when we will be trying to pick up its value, the answer will remain the same. The determinant of a square matrix obtained by interchanging two rows or two columns is negative of the given determinant. What is meant by this? This is the original matrix. You have changed this. You have brought this over here. No doubt this will come down. This will remain the same. If you change this, the matrix or the determinant value will be with the negative sign. If its determinant value is 6, after interchanging, its determinant value will be minus 6. If two rows or two columns of a determinant are identical, you can see over here, row number 2 and row number 3 are 0. Straight away, its determinant value will be 0. If the fourth one, if all the elements or a row or column is a square matrix are multiplied by a non-zero number, that is k, then its determinant value will be k times. Here you can see that you have a matrix 1, 6, 5, 3, 2, 1, minus 2, 0, minus 3. Its determinant value is 56. One of my learners want to multiply this matrix by 2. So I can straight away say that its matrix value will be 2 by 56, that is 112. Now, if elements of one column are expressed as sum of two elements each, then the determinant can be written as the sum of the determinants. You can see over here, your original matrix is 1, 6, 5, 3, 2, 1, minus 2, 0, minus 3. One of my learner wants that column number 3 should be split up. I said, okay, split it up. One of my learners said that 5 can be written as 2 by 3, 2 plus 3. Okay. Somebody said, what to do with 1? I said, add 0 plus 1. Mathematically, it's not going to affect anything. Somebody said, what to do with this minus 3? I said, you can place it up with 2 plus minus 5. Then, what to do? I said, split up. 1, 6, 2, 3, 2, 0, minus 2, 0, 2 in one matrix. And in the second matrix, it will be 1, 6, 3, 3, 2, 1, minus 2, 0, minus 5. When we are going to get the determinant value of these two matrices individually, you will get for the first one minus 24 and the second one 80. When you will be adding this, you will be getting 56. What was the original value? This was the original value was 56. And you are splitting it, it doesn't make any effect. Averagation increases, but it doesn't make any change in the determinant value. Now, one of the most important part of determinant, that is minor and cofactors. This will be useful while we will be doing solution to linear equations. Now, I will be telling you how minors are calculated. You are being asked to calculate the minor of A33 cross 2. A32 is A3 cross 2. That means row comes first and the second part is column. What you will be doing? Remove third row. That means 6 to 1 removed. I'm talking about the minor. Minor of 3 2. I will be removing the third row and second column. What I will be left with? 7, 9 and 3, 4. Calculate its value. 7 into 4 minus 9 into 3 comes out to be 1. What is the value of A23? A23 means remove second row, third column. You are left with 7, 5, 6, 2. 7 into 2, 14, minus 6 into 5, 30. 14 minus 30 is minus 60. Now, I tell you something about cofactor. There is a very simple asking to be performed when we are finding out the cofactors. For cofactors, you have to keep one thing in mind. That is the nature of these two numbers. When you are going to add these numbers, 2 plus 3 is 5, 3 plus 2 is 5. This is an odd number. Wherever you are going to get an odd number, add, multiply that numerical number with minus 1. Straight away from minor, you are going to get cofactor. And if it is an even number, remain it as it is. Either it is minus 2 or 2. That doesn't make any difference. I will show you how it will be done. For a matrix, we have to find the cofactors. A11. I have to find the cofactor of A11. What I will be doing? I will be removing first row, first column. We are left with 2, 1, 0, minus 3. First of all, we will be finding the cofactor. So minus 6 will be the cofactor. When we go back to the nature of these two numbers, 1 and 1, 1 plus 1 is 2. 1 plus 1 is 2. It is an even number. This will remain as it is. Okay. Now we move to A12. A12 means removing first row, second column. You are left with 3, 1, minus 2, minus 6. We will be multiplying this 3 into minus 3 is minus 9. Minus 9 plus 2. Minus 9 plus 2 is minus 7. This is your cofactor. When we are, this is your minor. And for cofactor, see the nature of this. 1 plus 2 is 3. 3 is an odd number. In cofactor, in minor you got minus 7, and in cofactor you're getting 7. This is the only difference. Whenever you are going to find out the cofactor from the minor, see the nature of these two numbers. If we are going to add these two numbers, if it is odd, the sign will remain the same. And if it is even, the sign will remain the same. And if it is odd, multiply that number by minus 1. Now, moving further, problem is same. I'm just A21. That means I will be removing second row, first column. Yeah, I'm left with 6, 5, 0, minus 3. 6, 5, 0, minus 3 is minus 18. When we are finding out cofactor, this is 3. 3 is an odd number. I got minus 18. I will be multiplying it by minus 1. I got, when 2, 2 comes, second row, second column. I'm left with 1, 5, 2, minus 3. 1, 5, 2, minus 3. This is minus 3 plus 10. This comes out to be 7. No change, because 2 plus 2 is 4. 4 is an even number. This is the difference. Similarly, A23, it is an odd number. Whatever is the answer you are going to get, multiply it with minus 1. This comes out to be minus 12. A31, minus 4. 3 plus 1 is 4. 4 is an even number. 3 plus 2, 5. You are going to get minus 14 over here, because since that is an odd number, we will be multiplying minus 14 by minus 1, so we will be getting 14. Similarly for 3, 3, initially we are getting minus 16, so we don't have to change the value. It will be minus 16. Moving further, because now you are aware of what is meant by the value of the matrix, you are aware of about the cofactors and adjoint. Now we will be moving further to the most important part of the application, that is solving a system of linear equation by Cramer's rule. Initially, we'll be taking two equations. That means it will form a 2 by 2 matrix. You can see over here, there are two equations, ax plus by equal to e, cx plus dy equal to f. These two equations are given to us. We have to calculate the determinant value. First of all, here it is represented by delta. What we will be doing? We will be picking these coefficients a, b in the same order. Don't change the order. a, b, a, b, c, d, t, d. Correct? Now, when we have to calculate the value of x, what modification we have to do over here? We will be changing the first column by these numbers E and F. So ASC will be replaced by EF. In delta Y, this BD will be replaced by EF. These three things for calculating the value of x. Delta is AB, CD. Delta X is replacing AX, column AC by EF. And for delta Y, we will be replacing column number 2, BD by EF. Now, how to get the value of x? X is delta x divided by this delta. And y is equal to delta y divided by delta. Now, your question may come into your mind that what will happen if we get the value of this delta as 0? Because we will be dividing the value of delta x by 0 and delta y by 0. We are not going to get anything. That means if delta x is equal to 0, we cannot use this Cramer's rule. This was for the 2 by 2 matrix. That means for two equations. Now moving further, three equations. See the change. Theory will remain the same. What we want, we will be changing that. Delta has to be calculated. So in delta, you have to take all the coefficients in the same order. You can see over here, A11, A12, A13. Don't change the order. The way you are picking up the coefficients from the equation, whatever is given, in what way it is given in the problem, you have to pick that only. A11, A12, A13. Then comes A21, A22, A23. Then comes your A3, A31, A32, A33. Don't change the order. Now, then comes your delta x1. What we will be doing? We will be replacing these three values by these three values. You can see over here, it has been replaced. These values will be replaced by these values. Similarly, for delta x2, I will be replacing these three values by this in the center one. And similarly for delta x3, I will be replacing these three by these two. Got it? Same method has to be performed. X1 is equal to delta x1 by delta. X2 is equal to delta x2 by delta. X3 is equal to delta x by delta. Again, if we get delta x equal to 0, we cannot find out the problem. Now, different condition arises when we will be getting the problems. Matrices are enclosed with square brackets, while determinants are denoted by vertical bars. Shown it in the initially when I was talking about the determinants. A matrix is an array of numbers, but its determinant is a single number. So what are the different conditions about linear equation. Suppose if we have delta equal not equal to 0, so we have a unique solution and the system is consistent. Now, if delta is 0 and all delta x, delta 1, delta 2, delta 3 are also equal to 0, then we have infinite solution and the system is consistent. But third case is delta is equal to 0, but at least one of delta 1, delta 2, delta 3 is not equal to 0. Then the system has no solution and the system is inconsistent. This is, we will be finding out the nature of the solution when we will be calculating these values. That means delta, delta x1, delta x2 and delta x3. Now the question arises, how? Here comes how. We have a 3 by 3 equation. That means we have three variables, x, y, z. We will be picking up the coefficients of these equations in the same order in which the problem, it has been given in the problem. Your delta is 1, minus 4, minus 1, 2, minus 5, 2, minus 3, 2, 1. Be careful about the numerical value. Whatever it is minus 4, the minus 4 will be picked. Minus 5, minus 5 will be picked. Minus 3, minus 3 will be picked. Don't change the sign anywhere. Now, how to calculate this determinant value? If you remember what I will be doing, how I will be calculating this, I will be starting with this. This I will 1, it is over 1. I will be removing this and I will be removing this. I am left with this. Diagonally I will be multiplying. Minus 5 into 1 is minus 5. Minus 2 into 2 is 4. In the second one, we have to take minus, but it has minus over here. So we will be changing the sign plus. Plus 4 will come. We will be removing this and we will be removing this. So we will be left with this and this. So 2 into 1 is 2 and minus into minus is plus. Plus 2 into 3 is 6. You can see over here. Third one is initially, as per the standard, it has to be plus, but here it is minus, so minus will come. Minus 1, we will be removing this and we will be removing this. We will be left with this. This means 2 into 2, 4, minus 15. On simplification, we get 34. 34 is not equal to 0. That means we have a unique solution to this problem. Now, how that unique solution can be calculated? I told you for delta x1, replace this by these values. You can see over here, 1 has been replaced by 11, 2 has been replaced by 39, and minus 3 has been replaced by 1. We will be performing the same exercise what we have performed over here. Starting with 11, remove this, minus 5, minus 4, minus 9, minus is over here, we will be changing the sign, the plus 4, remove this, 39 minus 2, third one was to be plus, but it has been minus over here, replace this minus 1, remove this, 78 plus 5, 83. Simplify it, you will get minus 34. One thing. For delta x2, replace this one, this second column by these three numbers replaced. Remaining two columns will remain the same. Parent is not going to change. Similarly, open up, you will get a value of minus 1. Third one, this was your original matrix, replace this by 11, 39, 1, replaced. Open it up. This comes out to be 270. Now, going back over here, your x will be minus 34 by 34, which comes out to be minus 1. Delta x2 minus 170 divided by 34, which comes out to be minus 5. Delta x3, this is 272 divided by 34, which comes out to be 8. That means we can say that the solution to this equation, as these equations have a unique solution, and that unique solution is x is equal to minus 1, y is equal to minus 5, and z is equal to 8. Now the question arises, how to know that this solution is correct? After doing this much of exercise, how we are going to get whatever we have calculated is correct or not? Going back to the problem, you can see over here, we have three equations rather. This seems to be somewhat simpler in viewing it. I will just place the values of x, y, z in this equation. Now check it out, whether we get 11 or not. Replace x by minus 1, y by minus 5, and z by 8. Minus 1 plus 20. Minus 1 plus 20 is 19. 19 minus 8 is 11. That means we can say that our this calculation is correct. That is, to check it, what the value you have calculated is correct or not. Now we move to unit 3, that is inverse of matrix. Again, this matrix inverse will be used in solving these equations by another method. Inverse is basically the inverse of a square matrix, n cross n matrix, is another n cross n matrix denoted by A minus 1. What we write is A inverse, such that A into A inverse is equal to A inverse into A is equal to identity. Multiplying a matrix by its inverse produces an identity matrix. Note, however, that all matrices have an inverse. If the determinant of a matrix is 0, then it will not have an inverse. These are the conditions, what we have to remember. Since matrix whose determinant is 0 is known as singular, we stimulate the condition that only a non-singular matrix will have an inverse. Such a matrix is also called invertible matrix. What are the properties of inverse matrix? A square matrix is invertible if and only if it is a non-singular. The inverse of a matrix is matrix itself. A inverse has been calculated, and again we are calculating the inverse of it. So we'll get the same matrix. Now, the inverse of the transpose of a matrix is same as the transpose of its matrix. That means A transpose inverse is equal to A inverse transpose. If we have seen this, if A and B are two invertible matrices of the same order, then A and B is also invertible, which holds true that AB inverse is equal to B inverse A inverse. We have seen this earlier in our session. Now, how to calculate inverse using adjoint of a matrix? Suppose we have a square matrix of order n and a square matrix B of order n is called the inverse of A if A cross B is same as B cross A, which is equal to identity matrix. The inverse is denoted by A minus 1 We write it B is equal to A minus 1. A into A inverse is equal to A inverse into A, which is an identity matrix. So by that, we come to a conclusion that A inverse is equal to adjoint of A upon mod of A. You have heard of how to calculate adjoint of A? I will tell you. You know how to calculate mod of A, and now we will see how inverse is calculated. Pick up a problem. We will see how all these things are calculated in this page. Your matrix is 1 minus 2, 3, 3 minus 1, 4, 2, 1 minus 2. Here we will showing so many things over here. A into A inverse will be equal to A inverse into A will be equal to I3. I3, why I3? What does I3 means? I3 means identity matrix of order 3, 3 by 3. That means diagonal elements will be 3 and diagonal elements will be 1 and they will be 3 in number. Remaining all elements will be 0. Calculating its value, determinant value, so we will be getting minus 50. You know how to find the minor and the cofactors. Adjoint of A is basically transpose of cofactors. We know that they have calculated the minus and cofactors. A11 is minus 2, A12 is 14, A13 is 5, A21 is minus 1. You can see over here that where the summation of rows and columns is odd, a minus sign has been placed. These A11, A12, A13, A31, A22, A323, A31, A32, A33. You can see this is 1 plus 2. 1 plus 2 is 3. 3 is an odd number. We have straight away put a minus sign over here. Alternately, again this minus 1. Again this 2 plus 3, 5. Again this 2 plus 3, 3 plus 2, 5. Now, these are the cofactors. Your adjoint is transpose of cofactors. That means this will be replaced by this. This transpose comes out to be, I will be placing all these numbers from here. Minus 2, 14, 5, 1, minus 1, minus 8, minus 5, and minus 5, 5, 5. Correct? I have to transpose it to get the adjoint. I will be writing this in the column form. Minus 2, 14, 5, minus 1, minus 8, minus 5, minus 5, 5, 5. This is the adjoint of A. Now we have to calculate what? Inverse. A inverse is equal to adjoint of A upon mod of A. We have the value of mod of A as 15, which will be minus 15 minus 1 by 15 into adjoint of A. This is your inverse. Now what we have to calculate? A into A inverse. We cannot change the order. A into A inverse. This minus 1 by 15 will be taken front. And now multiplication comes this way into this way. And this way, this way. This one with this. Similarly, we will be following this. What we are going to get? This. Take 50 minus 15 out. Minus 15 by 15 and this minus will make 1. This is 1. After taking minus 15 out, you will be left with this. This is I3. This is what I told you. It will be an identity matrix of order 3. There will be elements in the diagonal only and there we will be having 3 ones in that diagram. This A into A inverse has been done by me. You are requested to calculate A inverse into A. That means you will be placing this first and this over here and see you get the same answer or not. This is again something which is very interesting to understand. What I'm going to do by elementary operation method, or we can say row transformation, we will be using rows only. Keep one thing in mind, we will be using rows. That means we will be transforming rows by multiplying, adding, and subtracting. All the 3 things we will be doing. We have to find the inverse of this matrix. 1, 2, minus 2, minus 1, 3, 0, 0, minus 2, 1. Initially, write this matrix at A equal to in this form. Third step, this matrix will be equal to, this is a 3 by 3 matrix, so you have to write an identity matrix of 3 by 3 order. This is 1, 0, 0, 0, 1, 0, 0, 0, 1 into A. Now listen to me what I am telling you. The most important thing which has to be kept in mind, how to find the inverse by elementary row transformation method. You can see that this was the problem given to you and you have transformed it till here. Or you can say that this is what has been transformed by you. What we will be doing and why we are doing this. What we will be replacing this matrix in identity matrix form. What we will be doing? We will be transforming this matrix in an identity matrix form. Whatever transformation we will be performing over here will simultaneously be performed over here. This will be changing to something and this will be changing to an identity matrix. That means we have to keep one thing in mind. We have to convert these matrices in 1, 0, 0, 0, 1, 0, 0, 0, 1, 4. Correct? Now, first step. Move to row 2. If we talk about row 1, we already have 1 over here. So try to avoid it. Don't use it. We will be using this row for making this element 0. Because we have to make 1, 0, 0 over here. Straight away, we will be transforming this. If mathematically, if I add this 1 to this 1, I will get 0. How to write it? Apply. R2 tends to R2 plus R. That means in this row, all over this method, this will be performed. Add minus 1 plus 1, 0, 2 plus 3, 5, minus 2 plus 0, minus 2. Correct? Rest, all the elements will remain the same. Don't change it. 1, 2, minus 2, 1, 2, minus 2. This has been obtained after performing this transformation. Then comes third one. It will remain the same. And here also, same operation will be added. R2 plus R1, R2 plus R1, 1, 0 plus 1 is 1. Rest, everything will remain the same. Now, we can see that we have obtained this. Now, move this. We have to make this 0. What to be performed? What I'm doing? R2 tends to 1 by 5 R2. That means again in row 2, I'm making this as 1 because I'm already having 1 over here. Good. So I will be dividing all these elements by 1 by 5, or I will be multiplying all these elements by 1 by 5. This will remain same. Multiply this, so this will become 1 and this will become minus 2 by 5. This will remain the same. This will remain the same. This will be 1 by 5. 1 by 5, 0, 0, 0, 1. Got it? Now, you can see that in the diagonal we have, we want diagonal. That means now what we have to do? We have to perform in that way that these three and this one can be converted into 0. Now what I will do? I will be doing transformation in row 1. Row 1 minus 2 times of row 2. Your question arises why we are doing it. When I will be subtracting 1 minus 0, this is not going to change. But when I will be subtracting 2 minus 2, this will become 0. And let it be what this is coming. Minus 2, minus 2 plus 4 by 5. Let it be. This comes up to be minus 6 by. Don't be worried about it. What the transformation you are doing over here, the same transformation has to be done over here. So we will be getting 3 by 5 minus 2 by 5, 0. This will remain the same. This will remain the same. Transformation, this will remain the same and this will remain the same. That means we can say that transformation has been done in these rows. Next step. R3 tends to R3 plus R1. What is that? R3 tends to R3 plus R1. R3 plus R1. The transformation has been done. The same transformation will be done over here. R3 plus R1. Now, you can see that we have 1, 0, 0, 1, 0, 0. Problem is of this. Multiply this R3 by 5 times. When you will be multiplying R3 by 5 times, this will become 2, this will become 2, this will become 5, this will become 1. Got it? Rest, all the elements will remain the same. Now, what we have achieved? 1, 0, 0, 1, 0, 0, 1. This is creating a problem. We will be removing this problem in this tableau. R1 is equal to R1 plus 6 by 5 times of R3. When you will be adding 1 plus 0, will remain 0, 0 by 0. Same, then you will be, R1 is minus 6 by 5, and you are adding 6 by 5 into 1. So minus 6 by 5 plus 6 by 5 is 0. You are going to get 0. What was the another thing? You have to change this to 0. For changing this to 0, we will be doing transformation in row 2. Row 2 will be row 2 plus 2 by 5 times of row 3. What will happen? This will become 1. This will become 0. This is 1. This will become 0. 0. Same transformation will be performed over here. You can see that everything has been transferred. Original matrix has been, this one was your original matrix. This one was the identity matrix. What you have done? You have converted the original matrix into an identity matrix, and identity matrix has been converted into another matrix. This is what you have obtained over here, is your inverse. Why inverse? Because A inverse into A inverse into A is an identity matrix. Okay, this is how to find Matrix by how to find the solution or matrix inverse by different methods. We have seen how we can solve the equations and how the inverse can be found out by method as well as by row transformation process. Now, any question from anyone?
Yeah, we have had enough stuff. We may
You
come up
have
with
enough.
questions after.
Have you understood the concept?
Yeah, but since learning is still a process, once we get back to the stuff again, we may come up with questions.
But you have to work
Probably in the
upon it
next
because
class.
this is but you cannot leave it because in the next class I will be starting with if you have any problem you can ask me in the next in that next session I will be starting with unit 4, that is application of matrix and determinant in practical situation. Here in that case you will be asked to calculate inverse as well as you have to multiply a lot. So work upon on the multiplication and how to calculate inverse. Any question from anyone now?
Sorry, just wanted to find out, like, quite right, I understood the first part. I think I just a bit on the last part that it didn't really get clearly, but I feel after going through, I'll be able to understand. So possibly, like, after going through, in case you have any questions, how may we be able to ask you? Do you have to wait for the next class, or there's another method we can use for contacting you for asking questions?
I don't have any problem. Whatever you just go through the content once to the video, try to solve it. If you have any problem, I will be discussing it in my next session. Or I can do one thing. I can start it. I will start my session with the initial 5-10 minutes for how to solve the linear equation problem.
All right, thank you so much.
Thank you. Bye bye. Have a nice time.
Thank
Bye.
you.